Pre-calculus, we're in chapter 3, and right now we're going to cover sections 3.1 and 3.2 kind of mixed together. So we're looking at exponential functions and logarithmic functions and their graphs. We're going to look at this as if it's completely new. I know some of you have probably worked with it before, but we're going to come at it as if we didn't really know this stuff. So your objectives are listed, but let's go down here where it says 3.1 exponential functions. I did try in these notes to kind of mark where I flip-flop back and forth from section to section. So an exponential function. We're used to exponents being the number and the base being the variable if we're going to use something like that. But in this case, the exponential function f, here's my function, with a base a as a power of x, is denoted by this that I just drew, where a is greater than 0 and a cannot equal 1. Okay? A is greater than 0 and a cannot equal 1. So let's imagine for just a minute, and we are going to graph these on our calculator in just a little bit, but if I had a equals 1, 1 to the 0 power is 1, 1 to the 1 power is 1, 1 to the 2 power is 1, guess what? That's just a horizontal line at y equals 1. If my a value is lower than 0, so this was if I had 1 to the x. Let's say I had negative 3 to the x. Okay? So in this case, negative 3 to the 0 is 1. Negative 3 to the 1 is negative 3. Negative 3 to the 2 is 9. And then we jump down to negative 27, and then negative 81, and then negative 243. This graph is going to flip-flop back and forth so many times. It gets so much bigger and bigger that this graph does not even come up when you use your calculator. The calculator doesn't graph this because your base cannot be a negative number. Okay? So, x is any real number, but my a, my base, has to be greater than 0 and not equal to 1. Let's talk about evaluating these exponential functions real quick. So use a calculator to evaluate each function at the indicated value of x. So in other words, they want you to plug in for x. So f of negative 3.1 would be 2 to the negative 3.1 power. Looking at this in our TI calculators, we would push 2, use the little exponent or the caret button, and then I think it was negative 3.1. We're going to round to 3 decimal places for the whole section unless we're told otherwise. So 0.117. 0.117 is what this is equal to. I could also do this on Desmos. 2 raised to the, sorry about that, negative 3.1 power. Gives you the same answer. All right, so 2 to the negative pi, let's put that in. 2 raised to the negative pi, enter. 0.113. If you pay attention when I'm using my calculator, the buttons light up red as I touch them because I know you can't actually see me touching them. So if you need to slow me down so you can see that, that's fine. 0.6 raised to the 3/2 power. 0.465. This is just a matter of plugging in. 0.465. Now, all of these had different bases, 2, well, not all of them, 2, 2, and 0.6. We used our powers for x, and we plugged in. These were all just regular old exponential functions. Next, we're going to talk about evaluating natural exponential functions. So we have a new number. The number is e. E, which I'm going to write as e to the 1, because your calculator has a tendency to expect a power on that. E is a number that is approximately equal to 2.718281828, keeps on going. On our TI, E is right here above the LN button. So in blue, second, and then the LN button. And if I want E to the 1, which is just E, there's my 2.71828. However, we are looking for plugging in a -2, a -1, a 0.25, and a -0.3. So E to the -2. Power's already there. 0.135. Somebody asks all the time if they need their leading zero. I prefer the leading zero before the decimal so that I know you have a decimal there. Sometimes your decimals are not always easy to see. 0.368. Let's see. What was the next one? 0.25. So E to the 0.25, 1.284, and E to the -0.3, 0.741. 0.741. If I were doing that section using Desmos, I use the actual E button from the alphabet and then raise it to a power. Oops. Raised to the, what was one of them? 0.25. Sorry about that. So 1.284, which I think is what I had already written. Yes. All right, so we're going to stop right there so that we have some short bursts of videos instead of trying to give you everything at one time. The next video we'll be back working on graphs of exponential functions.